Good evening, sir.
Good evening, Shravan. Just wait for 1 minute till others are joining, and then we can start.
Yes, sir.
Good evening, sir.
Yeah, good evening. Just another 1 minute. We are starting in another 1 minute. Okay, let everyone join. So just in 1 minute, we'll be starting. Okay.
Yes, sir.
Okay. So what do you think? I think today we shall be doing physics. In the last class, we did conservation of momentum. If you remember, we did the formula for conservation of momentum. So till the class starts, I just want all of you to just go through the notes of conservation of momentum. Look up at the formula. Try to say what all questions were solved during that time.
So can you explain conservation of momentum once more?
Okay, surely. I'll just go a little bit with that and then we'll continue with the questions.
Yes, sir.
Okay. We also did the recoil velocity of the gun. If you remember, anyone? Did we do the recoil velocity also?
Yes, sir.
Yes. Okay.
So when
In the last class, last to last class, I think. Last class was bio, and before that, I think we did the same thing.
okay, sir.
So, okay, now I think we can start. Whoever has come, that's final. Okay, good evening, everyone. Good evening, Harshit. Good evening, Ikta. Anyone having any doubt during the classes, ask
No,
for
sir.
your doubt. Okay. See, in it may appear to you that your doubt is so small, but your doubt is not actually small. It's a big doubt. Okay. If I clarify your doubt, so some other people's doubt also get clarified. You are responsible for clearing your doubt. Okay. So if you ask your doubt, whatever it may seem to be a silly doubt, ask it. Okay. See, I know one thing about the study, that if you more study means more doubt. Okay. No study means no doubts. Okay. So if you have no doubts, then you have no studies.
Sir, actually in my the textbook which I use is the rationalized one. In that
Yeah.
I don't have about conservation of momentum.
Okay. So even if you don't have, you should be going through that conservation of momentum part. Okay.
Okay, sir. In the textbook, it's not given at all.
Okay. So I can show you both the books. I have both of them.
Okay,
So
sir. Okay,
what
sir.
is important that we do, and for the competitions, we are not actually preparing for your just class exams. Okay. You should be high enough from your point of view. Okay. So now your target is competition. So when you sit at the competitions, of course, you should be aware of conservation of momentum. Yes, Rohit, what happened?
Sir, could I leave by 7:45? I have a class. I have an exam tomorrow.
Okay, so obviously you can at 7:45.
Yes, sir.
For the conservation of momentum, we know that the conservation of momentum in the absence of an external force. So it's in the absence of an external force, the total momentum remains conserved. Total momentum remains conserved. Okay. The total momentum remains conserved if there is no external force acting on either system of the particles. If you have a system of particles, so then if the external force is zero, then we say that the total momentum is conserved. When I say total momentum is conserved, I mean the total initial momentum should be equal to the total final moment. Total initial momentum equal to total final momentum. So total initial momentum is given by the formula m1u1 plus m2u2 if there are two objects. Okay, so the total initial momentum will be given as initial momentum of the first plus the initial momentum of second. Okay, the total final momentum will be given by final momentum of the first, which is m1v1 plus the final momentum of second. So if you have an interaction occurring between the two bodies at any instant, so their total initial momentum should be equal to the total final momentum. And with this formula, we had found out the formula for recoil velocity of the gun. We had done different other formulas also for this. Okay. So I'll just show you what are the different. Okay, so just I think you are saying about the rationalized syllabus. Let me check about that also. Oh, it's not chapter
So
9
chapter
then.
8, sir, actually it's chapter 8. Chapter 7 is motion.
Okay, so it's chapter 8.
Sir, I think few chapters of biology are deleted.
Yeah, I know. So chapter 8.
Sir, you kept a rationalized book force class 8.
Class 9 force, right?
Sir, that will be enough.
Just
Chapter
1 minute.
and chapter 8.
Chapter 8. Again, it comes gravitation.
Sir, you just search rationalized book force class.
Okay.
Yes.
I think this is the book that we are searching for. This is your force It has 17, and this one is the rationalized one with 13 pages. Okay, so yeah, of course, you don't have a see, you say that conservation of momentum is not there, but it is. See, all these examples, they are for the conservation of momentum. Okay. Now, since we had done in the last class, we had done a few questions. Did I give you any of the homework? Third law of motion, action and reaction, that is what. Okay, let's start with these questions now. Now we'll be doing out all the questions of this chapter. So your first question is, an object experiences a net zero external unbalanced force. Is it possible for the object to be traveling with a non-zero velocity? If yes, state the condition that must be placed on. So what are the conditions that should be placed on it? Okay, anyone who can answer this question?
Sir, in the question, the net force is 0.
Okay, an object is experiencing a net zero external unbalanced force. Okay, so is it possible for the object to be traveling with a non-zero velocity?
Yes, sir, it can.
So how it is possible? What are the conditions then?
Sir, it must be moving on a frictionless surface.
Yeah, it must be moving on a frictionless surface so that the external force is zero. It is like that. If there is no force acting on it, here we have no force acting on it, that means the force is zero. It means acceleration is zero, that is there is no change of velocity. Okay, there is no change of velocity, but surely there can be a change of there can be a constant velocity. Okay, so object is experiencing a net zero external unbalanced force. So here if I get force equals to 0, I will be equating this to the formula F equals to ma, and this equals to 0. So I get acceleration as 0. It means acceleration is 0, and hence I can get, if I use the formula of acceleration as v minus u by t equals to 0, I get v minus u equals to 0, then I get v equals to u. So that means the object can travel with a non-zero velocity. The condition is that it should be previously traveling with a certain velocity and it should be moving on a frictionless surface. Got it?
Okay, sir.
So the next question is, when a carpet is beaten with a stick, dust comes out of it. Explain. So why does the dust come out of it?
So due to the inertia of rest.
Hmm?
Due to inertia of rest.
Inertia of rest. Okay, explain it out in your
Sir,
own words.
because due to inertia of rest, because the dust which gets stuck on the carpet when it's beaten with a stick, it suddenly experiences motion, so so the dust comes out.
Okay. So due to inertia of rest, I have dust particles. They are in the state of rest. But when you beat it, the carpet comes in the state of motion. So the dust particles, they try to remain in the state of rest. So therefore, as a result, we observe it we observe the dust particles to be moving away from the carpet.
Yes, sir.
Okay, why is it advised to tie any luggage kept on the roof of a bus?
Sir, because the luggage is at inertia of rest, and when a bus suddenly comes to the stop, the luggage falls towards the backwards.
Sir, inertia of direction.
So inertia, obviously there is inertia. It is all the inertia of rest. You can talk of your inertia of direction also. You can talk of inertia of motion also.
Okay,
Okay. So you can talk of like when the bus is stationary, the luggage is need to be tied off, because if the bus starts moving, so when the bus accelerates, the the luggage due to inertia of rest will move backward. Okay, it will try to remain at its place. Okay, so when the bus moves forward, there will be a jerk experienced by the luggage in the backward direction, and hence there are chances that the luggage will fall backward. Okay, if you talk it in terms of inertia of motion, so again the similar thing. So considering the bus to be moving, if the bus comes to a rest, then the luggage will move forward. Got it? You can talk of here as the inertia of direction also. So instead of talking all the inertias, you can just put here due to inertia. Okay, the luggage will tend to be in its state of rest or motion. So if the bus starts moving, the luggage will fall off. Got it?
Yes, sir.
yes.
A batsman hits a cricket ball which then rolls on a level ground. After covering a short distance, the ball comes to rest. The ball slows to a stop because,
Sir, there is a force on the ball opposing the motion.
okay, so which is that force?
Sir, frictional force?
Frictional force, right? So here when the batsman hits a cricket ball which then rolls on the wall, the batsman, first option is the batsman did not hit the ball hard enough. This is incorrect. The second one is velocity is proportional to the force exerted on the ball. This is also incorrect. And the third one is there is a force on the ball opposing the motion. That is correct. Okay. And that force is the frictional force. Equal.
Sir, I have a doubt about frictional force.
Okay. So what is your
Sir, we have
question?
to, means if there is a heavy object and if we try to push it using less amount of force, it doesn't move. But if we push it harder to overcome the friction, there should be equal amount of friction, no, sir, because the reaction will be also equal.
See, frictional force is directly proportional to the load or the weight of the object.
Okay.
So heavier the object, greater will be the force of friction.
Okay, sir, but I'm asking why won't the frictional force be equal to the force which we give, keep on the object?
Okay. Just repeat your question once more.
Why won't the frictional force be equal to the force which we apply to the object, as according to the third law of motion?
See, this is very important to understand about the third law of motion. Okay. There is a question about the third law of motion also. Just I will show you. Okay. Just give me a minute. I will try to find out that question. Uh,
So you came to second law of motion.
okay. Okay. Just 1 minute. If I found it valid, otherwise I remember the question, I will put up the question over here. Okay. So Mhm. Give me one question. If I find that question, well and good. If no, I'll put it on my own words.
Sir, 11th. Is it the 11th question?
No, not the 11th. My question is like, yeah, similar to this, similar to question number 11. Okay. The question is, if action and reaction forces are equal and opposite, why don't they cancel each other? So who will justify this? Okay. So I will give you some options. You can take the help of that. If action and reaction forces are equal and opposite, so why they not cancel each other? Can anyone think of?
Whereas both of them are not acting on one object to cancel, they are acting on two objects. That's why they don't cancel.
Yes, yes, obviously. Here they are acting on two different bodies. The action and reaction forces, they are acting on two different bodies. For example, I have a massive block over here and I try to push it with a certain amount of force. So I am applying some amount of force F over here with which I am pushing, and there is a force of friction acting in the backward direction. So this is the force of friction. The red line, it represents the force of friction. This is your force of friction F, and this is the applied force. So when I apply some amount of force F, there is a force of friction which opposes the direction of motion. Since when I apply the force, this object tends to move towards the right. It tends to move. It may be moving or may not be moving, but currently I'd say that it tends to move towards the right direction. So when it tends to move towards the right direction, okay. Now the force of friction acts in the opposite direction, right? So here I am applying, this is me, I am pushing this. I am pushing this block. Okay. So I have applied a force F on the block. The block is applying a force F on me. Okay. So the two forces of action and reaction, they are acting on two different bodies and hence they cannot cancel each other. Now let us see your previous doubt. Okay, what was your previous doubt regarding the force of friction? From this one only.
Sir, I was asking that if we push a block,
Hmm.
so the according to the third law of motion, the equal amount of force will be acted on us. So why won't it means
Hmm.
cancelled?
So your doubt is clear?
So no, sir.
They are acting on two different bodies. Okay, okay, let's try to do it like this. I have this block, and so assuming there is no friction. There is no friction. I assume that there is no friction. There is a rope tied to it, and there are some people who are trying to pull it in opposite directions. So these are people who are trying to pull it in opposite directions. Okay. Like this. So considering each person applies an equal amount of force. Now, is there any force that is acting towards the right?
Yes, sir.
Yes. Is there any force that is acting towards the left?
Yes, sir.
Yes. Are the two forces cancelling each other?
No, sir.
Are the two forces cancelling each other?
No, sir.
Okay. So let me put put the same question in another way. Do you think that this block will move somewhere?
No, sir. But it can deform its shape.
It can deform its shape, but it will not move, right?
Yes, sir.
When it doesn't move, so it's not gaining any velocity, so its acceleration is zero. So can I say that the net force is also zero?
Yes, sir.
Yes. So can I say that the sum of the forces is zero? And when the sum of the forces is zero, so can I say that the forces are balanced?
Yes, sir.
Yes. So this is what I was asking. Since the forces are balanced, that means they are cancelling each other. So here, the two forces, they are acting on the same body and they are equal and opposite, hence they cancel each other. Okay.
Okay.
If the two forces, they were applied on two different bodies, do you think that they would cancel each other? For this case, which you are talking of with the friction. So let's try to understand with your example. You have your block over here. Okay. So now I am considering the two things differently. Two things means this is my body. I am considering my body to be different from this. Okay. So this box, I have applied a force on this block, and this block, the force that I have applied is equal to F, right?
Yes.
Okay. Now the force of friction, it acts on this block. The force of friction acts on the block in the opposite direction. Okay. So now my applied force is balanced by which force?
Frictional force.
Frictional force. So on this body, the net force on this body will be equal to, the net force here will be equal to capital F minus the force of friction. Is this
Yes.
correct? Okay. Now, as per the action and reaction, when I applied some force on this block, as a result, I also experienced a backward force. Will I experience backward force over here?
Yes, sir.
Yes. So it experiences a backward force over here. I experience a backward force which will be equal to F. Okay. So will my applied force cancel my backward force?
Sir, can you repeat?
Whatever force I applied, will it cancel my backward force?
So,
Okay. What are the total forces acting on my body?
sir, F and F. There
On
are two
me,
forces.
on me, on me. What is the force acting?
One force F.
The applied force F, which I applied, it is the same force that is acting in the backward direction. So by this, I should be moving in the backward direction.
Yes, sir.
Yes. But why I don't move in the backward direction?
Sir, we are resisting it.
We are.
Resisting.
So from where we are resisting it?
So we are trying to move forward, while it's trying to move us back.
No. Okay. If the surface was frictionless, had there been no friction. Okay. In case there was no friction, so in that case, what would happen? Consider that there is no friction over here. I'm considering that there is no friction. Now I have applied a force F on the block, and the block also applies a force F on me. So what will be the resultant? What do you expect now? Consider there is no friction. So what do
So
we expect?
it could be zero.
What could be zero?
Say resulted force.
Which force?
Net force.
Okay, net force is zero. But will the block move or not?
So, sir,
If there is no force of friction, so will the block move or not? Okay, let me simplify the problem. what is the net force on the block?
Sir, F.
F.
Uh,
So
and
will it
zero.
move?
Yeah. Yes, sir. It will move forward.
Okay, it will move forward. It is experiencing a net force, so it will move moving forward. Okay. And what is the net force on me?
Sir, net force. Mm, so net force is
Net force is
F. Will move
F.
backward.
So I will move backward. So now you got it that the two forces, they are not cancelling each other. We are gaining acceleration. Got it?
Yes, sir.
Yes. So is there still doubt in this?
Mm. Sir, I got, but I'm not understanding the main topic.
Now let us bring the friction again. So if there is friction, then what will be the net force on the block?
So net force would be zero.
It can't be, it will be the net force on the block will be F minus the force of
Yes,
friction.
sir. Force of yes.
Okay. And I will also be experiencing some friction since my tendency will be to move backward. So the net force that I will experience will be the force of friction minus F.
Yes.
Okay. Now, if the force of friction is less, so both of us will move. The block will move in the forward direction and I will move in the backward direction.
Yes, sir.
Okay. If the force of friction is more, so even after applying the force, neither the block will move, not I will move.
Net force will be zero or
Yeah, net force will be zero. Net force on this complete system is zero. But net force on each of the block, that's different. Each of the body, that's different.
okay,
Got
sir.
it?
Yes.
Okay. So let's concentrate on our questions. Okay, we did this question number 4. Now question number 5. For question 5, a truck starts from rest and rolls down a hill with a constant acceleration. So a truck starts from rest and rolls down a hill with a constant acceleration. It travels a distance of 400 meters in 20 seconds. Find its acceleration. Find the force acting on it if its mass is 7 tons. 1 ton is 1000 kilograms. Okay, so is there anyone who can explain? Yes.
Sir, actually, we have the distance, time, and initial velocity. So we can use the third equation of motion to find the acceleration.
Mhm. Okay. So a truck started from rest. We have the initially giving the truck having an acceleration. Initially, the truck is at rest and then it comes with a certain, it travels a certain displacement. So here the truck was at rest and its initial velocity was 0. It rolls down a hill with a constant acceleration. It travels a distance of 400 meters. Here it travels a distance of 400 meters and in 20 seconds. Time is also given to us 20 seconds. You have to find the acceleration during this duration. What will be the acceleration for this part of the So, which formula should we use now?
S is equals to ut plus 1 by 2 at square.
Yeah, we'll be using S equals to ut plus 1 by 2 at square. Since we know all the variables here, the value of all the variables is given.
So I'm getting acceleration of 0.1 meter per second square.
So I can find, okay, what's the value you get?
0.1 meter per second square.
1 by 2 multiply acceleration multiply by time, that's 20 squared. So you
No,
get 400 equals to 1 by 2 multiply acceleration multiply 20 squared. So 20 squared is 400. 400 and 400
sorry,
cancel. So I get acceleration as 2 meter per second.
2 meter per second.
Now the value of force F will be given by MA. So what is that MA equals to? Mass. What is the mass of the truck?
7,000 kgs.
7,000 kg.
7,000 into 2.
Sir, 14,000.
14,000 Newton.
14,000 Newton.
Sir, isn't it kg? Yes, sir.
I can also write it as 14 kilonewton.
Yes, sir.
Okay. Now let's say move to the next question. Question 6. Just go through the question. All of you go through the question and let's see if you are able to solve it out. If you are not able to solve it out, just inform after 1 or 2 minutes, I will start solving it. Just think of it. If you can solve it, start solving. A stone of 1 kilogram mass
Mm.
Okay, is there anyone who will be able to solve it out?
Sir, what is the formula of force of friction?
What is?
Formula for finding force of friction. How can you find
Just
friction?
okay, just go through the given situations. A stone 1 kilogram is thrown with a velocity of 20 meter per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meters.
Sir,
So this is the frozen surface of lake,
excuse me, sir.
50 meters. So the stone travels a distance of 50 meter over here. This
Sir,
distance is 50. Yes.
sir, is the answer 4 Newton?
Okay. Just let me check out now. So the distance
Okay.
is given as 50 meter and it is thrown with an initial velocity of 20 meter per second. It has initial velocity 20 meter per second and it comes to rest. So its final velocity is given as 0. Okay. The mass of the stone is given here. The mass of the stone M is 1 kilogram. Okay. So when the stone is moving on the ice, which is the force that is acting on the stone? Yes, which force is acting on the stone?
So frictional force.
Frictional force, right? So here the frictional force is acting on the stone. So only force that acts is the force of friction, right? There is no other force. The only force that acts on the stone is the force of friction, and it is acting in a direction opposite to the direction of motion, or I can say it acts in a direction opposite to the direction of displacement. So whatever acceleration or retardation is brought in this stone, can I say that that acceleration or retardation is brought about only by this frictional force?
Second, please repeat.
Can I say that the retardation of the stone is brought by the frictional force?
Yes, sir.
Okay. So yes. So I will first find out the acceleration that the stone is going, and then I'll find the amount of force.
Sir, the force is -4 Newton.
So I'll find the acceleration. The acceleration will be given as b minus u. So the different things which are given with that, I think you will be using the formula v
V
squared
square
minus
minus
u
U
squared
square
equals to 2a, right? This is the formula that will be used here. Since u, v, s, they are given, I need to find a. So I'll be using this. V is 0. So I have 0 squared minus u, that is 20 squared, will be equal to 2 multiply with acceleration multiply with displacement, which is 50. So you have negative 400,
is equals to 100A
100a, and hence acceleration is equal to negative
minus
negative 4
400 per
meter per
second
second.
square.
Got it?
Force
So
is
the
equals to MA.
force is equal to ma. F will be equal to ma. The mass is 1 multiply acceleration, that is -4. So you get -4 Newton as the answer. Got it? So force of friction is 4 Newton. Okay, now question number 7. Everyone has understood that question? Anyone having any doubt with this question number 6, 7, 5? Anyone? See, with the given conditions, you write down the things which are given in the question. Okay. You try to find out the unknown, and then you will get the answer. For question number 7, now you all of you think of this. I'm giving you 2 minutes for thinking for question number 7. All of you. Anyone like Yukta doesn't speak during the classes. Yukta, are you there?
Yes, sir, here.
So why you don't speak during the classes? No questions, no doubts. As I
Sir, I
told
was
you,
solving these questions.
what are you getting?
Sir, I was just solving these questions.
Okay, so solve it out. If you are not getting your answer, then tell that sir, I didn't get this one.
Okay, sir.
Okay, if you are not getting that, then just tell. All of you are may not be correct. Okay.
Sir, what
I,
is wagon?
yeah, what happened?
What is wagon?
Wagon.
5 minutes.
Wagon means the bogies or the compartments which are attached to the railway engine.
Okay, sir.
These are the wagon. So an 8,000 kilogram engine pulls a train of 5 wagons. That means there are 5 compartments which are being pulled by that engine. Think of it. I'm just drawing the diagram.
Sir, will A be 35,000 Newton?
Okay, A will be 35,000 Newton. Yes.
Sir, acceleration is 4 meter per second square.
Okay, let's see. So here on this track, we have 5 wagons. First wagon, second, third, let's say like this. And then you have an engine also. So your engine is pulling these 5 wagons. 1, 2, 3, 4, 5. So your engine is pulling these 5 compartments, and each compartment being,
Sir,
yes,
could you once explain this question? I'm getting a bit confused.
okay, so that's what I'm doing. Now see, this is your engine, and this engine is producing a force of, it is exerting a force of 40,000 Newton. So this engine is trying to make this train move in the forward direction, and it is putting a force of 40,000 Newton. Is this correct? Everyone has understood this? That the engine is applying a force of 40,000 Newton,
Yes, sir.
right? And there is a force of friction between the track, and that force of friction which the track offers, that force of friction is 5,000 Newton. So there is a frictional force that is acting over here. This frictional force is 5,000 Newton. So on this train, there are two forces acting: a forward force of 40,000 Newton and a backward force of 5,000 Newton. So what will be the net force? Net force will be the sum of these two forces, and we can take either one to be the positive one. So generally we take this force as the force applied by the train to be the positive force, and the force applied by the friction to be the negative force. So the net force we will get as 40,000 minus 5,000. But why minus? Because the forces are opposite. So we subtract them, and we get your net force as 35,000. Got it?
Sir, actually, second one was 2.2 Newton. Actually, meter per second square. D.
Okay. So everyone has got the value of net force. Everyone has understood the net force.
Yes.
Okay.
Yes, sir.
So here the net force is 35,000 Newton. And now I know that the net force F is given by mass times acceleration. The net force F should be equals to mass times acceleration. So the engine is pulling a total mass of 2,000 of each wagon, right? What is the total mass that the engine is pulling?
80,000 kg.
It's 2,000 multiplied with 5 plus 8,000, which is the mass of the engine itself. So can I say that engine pulls a mass of 18,000 kilogram?
Yes, sir.
So the net force is
35,000.
35,000. Mass is given as 18,000 multiplied with acceleration. So we get acceleration as 35,000 divided by
18,000.
18,000. So once you divide it, the three zeros cancel, and now divide 35 by 18. That is the amount of acceleration.
Yes. This is 1 minute. Check.
Yukta? Yukta? Yukta, are you there? It's 1.94. So acceleration we get as 1.94 meter per second square.
Sir, if we write 1.9, is it enough?
Yeah.
Okay, sir.
What happened? Just pardon again.
Can we write 1.9 meter per second square?
Yes.
Okay, sir.
Okay. Anyone? Yukta, have you understood? Are you there, Yukta?
Sir, can you hear me?
Yeah.
Okay, sir.
So have you understood this question?
Yes, sir, I got it.
Okay. Were you able to solve it out on your own?
So the first part I was a bit confused, but once I got to know the concept, I got it.
Okay. Afan?
Yes, sir. Yes.
Okay. Then is there anyone? Sharwan?
Yes, sir.
Okay. Did you get it?
Yes, sir.
Okay. Okay. So let's see the next question now. And I leave this question just for you people. Try it out. Question 8. Okay, so read it. Read it, and now I want the answer from everyone. I will start solving once everyone replies my answer. So once you get your answer, message your answer in the chat as a direct message to me.
Sir, we can directly apply force as MA here, right?
Force in?
Sir, we can directly apply force as mass into acceleration here, right?
Yes.
Okay.
Anyone got the answer?
Sir, I got negative 2550 kg meter per
Okay.
second.
Minus
What?
255 Newton.
Sir, I'm getting minus 2550 Newton.
The
So can we keep
answer
it in the
is,
chat box?
what happened?
Can we keep it in the chat box? It would be more easier.
Yeah, just give your answer in the chat box only. Just give your answer in the chat box only. I'll be able to check it. Okay, it seems I have got some of the answers over here. 2 people have answered in the chat box.
Sir, you can reply there.
Yeah, what happened?
You can reply.
Yes, yes. So just a very simple thing. Uh, an automobile vehicle has a mass of 1500 kilogram. So I write mass as 1500 kilogram. What must be the force between the vehicle and the road if the vehicle is to be stopped with a negative acceleration of 1.7 meter per second square. So your acceleration is negative 1.7 meter per second square. Now you simply need to use the formula F is equal to ma. Your m is given as 1500 multiplied with acceleration, that is negative 1.7. So we get, yes, what's the value you get?
So minus 2550.
It's minus of 2550 Newton. That is
Oh,
the answer.
okay, sir.
So I think everyone got the same answer.
Sir, I wrote the wrong unit, but I got the same answer.
Okay. So 2550, 2500. Okay. So take care of the units. Okay.
Yes, sir.
Okay. So I don't think. Okay. Quickly answer question number 9. What is the momentum of an object of mass m moving with a velocity v?
Sir, MV.
mv. Yes. Using horizontal force of 200 Newton, we intend to move a wooden cabinet across the floor at a constant velocity. What is the friction force that will be exerted on the cabinet? Okay, so I leave this question 10 and 11 for your homework. If you get that, well and good. Otherwise, we'll do that in the next class. Okay. So these
Sir,
questions,
yes, sir.
I'm adding this in the PDF. Question 10, 11, 12. Okay.
Okay, sir.
Okay, bye all of you. See you again in
Sir,
next
I had a
class.
doubt.
Yes, what is your doubt?
Sir, it's related to bio.
Okay.
Sir, I had some test on Monday.
Okay.
Sir, over there, it was an 8th grade concept in bio. It said if a girl follows healthy habits,
Mhm.
sir, the options were it will stop menstrual cycle. It will the girl will not have unwanted pregnancy and two other options. Is the correct answer the girl will not have unwanted pregnancy if she follows healthy habits and has hygiene?
No.
Sorry, I didn't have the exam. It was some
See,
shuffle exam.
Yes, sir.
uh, can
Yes,
you
sir.
share the complete question?
Sir, actually, it was online in school, but it said if a girl follows healthy hygiene and it gave some other options. The options for the
Yeah,
answer were
yes, sir.
the girl
Well,
would have a healthy, there won't be menstrual cycle. The girl won't have unwanted pregnancy and two other options, sir.
So these two options were incorrect.
No, sir. Won't it be the girl won't have unwanted pregnancy?
No, there is no relationship with the healthy hygiene and unwanted pregnancies.
no, sir. The question also added if she had knowledge about the process.
Yes, sir.
If she has knowledge about, see, just refer me the complete options. Okay, both the options are incorrect. The options seem to be incorrect. But for the optional questions, the final decision depends on all the four options. Okay.
Yes, sir.
Okay. So share complete
Sir,
question. Okay. Bye all
sir,
of you.
uh,
Yes.
Thank you so much, sir.
sir, what will vinegar have which can weaken our bones? Means
Yes.
if we keep any eggshell or egg in the vinegar, the shell will dissolve. Even our bones can become weak due to vinegar. What does vinegar contain?
So you are asking that effect of vinegar on bone, right?
Yeah, sir. Why will it have such severe effects?
See, our bone consists of mainly calcium phosphate.
Yes, sir.
Okay.
Yes, sir.
And calcium phosphate is a basic salt. It reacts with acids to liberate to break down calcium phosphate. So as the breakdown of calcium phosphate will occur with the help of the acid. So that is why a vinegar can have severe effects on bones. Got
Sir,
it?
I had one more question, sir.
Mm.
Sir, there was a question. So there was some diagram. It showed a needle and an uninsulated copper wire. The questions were, the options were, when will the needle show deflection? The options were when it's taken away from the wire, when it's tilted at an 180-degree.
Sir, the question was if they gave the
Yes, sir.
amount of electricity passing through it as 3. So what happens?
So actually that was from class 10, magnetic effects of electric current.
Yes, sir.
Sir, the question was actually they gave the amount of current as 3 and told which of the following will make the amount of deflection of the compass more.
See, all the questions can be answered
Sir, the,
once I see the complete question. Okay.
yes, sir.
Yes. Yeah. What happened?
Sir, there was a 3 voltage battery in that diagram.
See, whatever be the battery, whatever be the voltage, unless I see the diagram. Okay. What is the diagram? If you have a copper wire, okay, and suppose here some what I understood is that you have a copper wire, some current is passing through it, and you have a needle placed near it. What needle is this? Is this a compass
Solar
needle?
compass.
Okay, so you have a compass needle placed over here.
Yes, sir.
Now, what is the question?
Sir, the question was if we pass 3 volts of current through it, it shows the amount of deflection. What should we do? Which of the following is right to make the deflection more? 6 volts move the needle far or the move. There were other two.
Yes,
See,
sir.
if you move the needle away, the deflection will decrease. If you make the needle go towards the wire, the deflection will increase.
So
Sir,
we can do increase the voltage.
Yeah, even if you increase the voltage, then also the deflection will increase.
So the correct option will be 6 volts. Sir.
So actually, I can't say anything without looking at all the options, because what you are saying me, that is a verbal thing. Okay.
So
sir.
there were 50 questions asked about science.
Yes.
Yeah,
So
sir. 50
how
questions.
can I answer if I don't know the question?
Yes, sir.
Okay. So as per the given situations, whatever you inform me, I have provided the best solution. Right?
Okay,
Yes,
sir. Yes, sir.
Yes. Okay. Bye.
Thank you, sir. Bye, sir.
Thank you, sir.